This video explains the solutions to question 37 to 43. The first few questions ask you to draw ray diagrams to find image, and this statement tells you exactly what to do. In order to locate the image, you should draw two light rays from the same point of the object and see how they bend away from normal when they travel from water to air. In this way, the virtual rays represented by dotted lines may help you to locate the image. Now let's start. For question 37, in order to show that the body of the polar bear goes to the right hand side, you may draw a circle like this to represent the actual position of its body. Then we draw two light rays from the object, and these two light rays will then bend away from normal when they go to the interface, like that. And lastly, we draw the virtual rays. We produce the reflected rays backward by drawing virtual rays. In this way, then we may locate the image on the right. For the next question, you are asked to draw a diagram to show why the cone becomes visible when water is added. First, before water is added, light ray can only go in this direction, and then that light ray does not enter the observer eye. When water is added, then there can be two light rays, like these two, that bend away from normal. And then the next step is draw virtual rays with dotted lines. And the intersection of virtual rays is the location of image. For question 39, you are asked to draw a diagram to show why the bottom of the pool seems to be shallower, so it is not that deep. What you do is draw two light rays from the bottom of the pool, and they will bend away from normal. And then draw virtual rays. The intersection of virtual rays tells you the position of image. So the image of the whole bottom of the pool would be at this level, and so the pool would seems to be shallower. Question 40 seems to be a new question. Indeed, it's quite the same. Draw two light rays from the object. Draw virtual rays to find the image. Let's start to see what happened. In this case, the boy sees the fish, so there is light ray that comes from the fish. These light rays bend away from normal, so the boy would believe that the light rays come from this one, a little bit in front of the fish. So this is the image of the fish, and the fish seems to be closer. Question 41. It seems to be almost the same question, but in this way, the fish sees the boy. So there is light ray that comes from a single point of the boy, and these light rays bend towards normal because they move from air into water. So the light ray bends towards normal. The fish will believe that the light ray comes from the back, so the image of the boy would be there at the back. For question 42, it seems that not many people make mistakes, so let me show you the answers directly. If you are using 2.889 times 10 to the power 8 to be the speed of light, then you will get the answers in red. If you take the speed of light to be 3 times 10 to the power 8 for the speed of light in vacuum, then you will have all those answers in blue. Lastly, for question 43, I want you to repeat the calculation so that you will find the refracted angle R, and it will be 21 degrees. And using this 21 degrees, you may then find the second angle I here, and it is found to be 35, the same as the original I on the left hand side. So in the diagram, the incident ray and the emergent ray are parallel, but there is only a lateral displacement.